This has to be one of the most beautiful looking motherboards I've gotten my hands on. It's the MSI Z890 HTI Wi-Fi. I've had the chance to play around with this motherboard and do some testing with it, and it's definitely surprised me and exceeded my expectations in some areas. I've also got a 285K on hand and some fast DDR5 memory to go along with it to really get the most out of this platform. Is this motherboard at $370 worth your money? Let's find out.
Hey, if you enjoy content like this, drop a like, make sure to subscribe, and smash that bell so you never miss another video.
Hey, what is going on guys? Danny here, welcome back to the channel and I hope you've all been doing well. Today we're going to be checking out the MSI Z890 HTI Wi-Fi. This is a new motherboard, part of their 800 series lineup to support Intel's latest Arrow Lake architecture and the Core Ultra 200 series CPUs. I was actually quite excited to get my hands on this board and also the 285K because, as I've expressed in the past, the Arrow Lake architecture and the Z890 platform really intrigues me a lot with how much you can tune and tweak. I want to give MSI a shout out for sending this board over to us to check out and test, as well as helping me source a Ultra 9 285K so that way I can test out this board's capabilities in terms of overclocking, memory tuning, and also be able to show it compared to the previous generation 14900K. So stick around because there's going to be some interesting results later on. And just to preface this video and my future benchmarks video, I wasn't paid for this review at all, and all of my thoughts and my comments are mine and mine alone. So to start off, I wanted to show you guys an unboxing of the motherboard and give you guys an idea of what's inside the box. On the front of the box, you get a picture of the board with some labels indicating some noteworthy features, and then turning the box around we get further information on specs and support. Opening up the box, and we first get the Wi-Fi antenna that comes nicely packed in its own little box. Then we have the board itself wrapped in an anti-ESD bag. I've said in the past, and I'll say it again, but I would really like to see a bit of foam to protect these boards during transit. Then underneath the board we get some starter guides, cable labels, some SATA cables, a couple of RGB extension cables, M.2 standoffs with screws, and a M.2 standoff removal tool. They've also included a 24GB USB key which can come in handy for flashing the BIOS or just using it for transferring data. Let's dive into the aesthetics of the MSI Z890 HTI Wi-Fi, and I gotta say this has to be one of the best looking motherboards I've been able to get my hands on. Right off the bat, the first thing you noticed is the striking silver and white design, which is a refreshing departure from the typical black dominant motherboards we have in the market. The matte finish paired with clean, angular lines gives it a more modern and almost futuristic appearance. MSI has also included subtle accents, such as textured patterns on the M.2 heatsinks, which add a layer of depth and sophistication to the board's overall look. The RGB lit MSI Dragon logo on the I/O shroud is one of the few areas where RGB makes an appearance, and it's executed tastefully, enough to draw attention without being overbearing. This minimalist yet elegant design feels perfectly suited for a high-end white-themed build, and I can already picture how clean it would look in an all-white or light-colored case. Honestly, I'm kind of tempted on putting it in my personal rig, which was originally supposed to be a black case, but Amazon accidentally sent me a white version of the View 51, and then I just rolled with it. Overall, the Z890 HTI Wi-Fi strikes a balance between aesthetics and functionality, making it a standout for those looking to build a visually stunning PC. When it comes to features, the MSI Z890 HTI Wi-Fi is loaded and stands as a great contender packed with everything a high-end build requires. Starting with the power delivery, you'll have a 19-phase power layout. This board is equipped with a 16+1+1 phase Duet rail power system utilizing 90 amp smart power stages. MSI are using the MP-SS21 MOSFETs, and they are driven by the MP29005-A PWM controller. This configuration ensures exceptional stability and efficiency for power-hungry processors. That's 1,440 amps which are available for the CPU, which is more than ample for the Core Ultra 9 285K stock or for moderate overclocking. Though if you're going to be going for heavy, extreme overclocking, then you might want to look at a more higher end option like the Carbon or Ace, which have even beefier VRMs. When it comes to power delivery and VRM cooling, MSI have gone the extra mile with the Z890 HTI Wi-Fi to ensure stable performance even under the most demanding conditions. The board features an extended heatsink which definitely enlarges the surface area for heat dissipation, allowing high-end processors like the Intel Ultra series to run at full speed without thermal throttling. This is further complemented by high-quality 7-watt per meter Kelvin thermal pads on the MOSFETs and additional pads for the chokes, ensuring that all CPU cores can sustain high performance over long sessions. To enhance heat dissipation even further, MSI has incorporated a heat pipe that connects the two primary MOS heat sinks. This design effectively spreads the thermal load across a larger area, maintaining lower temperatures and consistent power delivery. What's also very neat is that MSI for this motherboard are using the new Reduced Load Integrated Level Mechanism, or RL-ILM for short. So this new RL-ILM was introduced this generation, and you'll find it on some high-end boards from other brands. But essentially, this new ILM is supposed to do what a contact frame does. This updated mechanism reduces the mounting force applied to the CPU, spreading the contact pressure more evenly across the integrated heat spreader, or IHS. As a result, the RL-ILM helps mitigate the risk of bending the CPU, a common issue with the previous design that often led to uneven thermal transfer and suboptimal cooling performance. The RL-ILM's benefits include a reduction in CPU temperatures by a few degrees under load, ensuring better thermal efficiency and enhanced stability during overclocking or high-performance tasks. MSI's integration of this technology allows for improved compatibility with a wider range of coolers, particularly those with flat or lapped cold plates. This makes the RL-ILM especially appealing to those enthusiasts looking to maximize thermal performance without resorting to aftermarket contact frames. You'll also find this motherboard equipped with dual 8-pin EPS connectors, which even for a 285K is more than ample, and what I really like about the placement is that they're located in a more open area as opposed to the corner above the I/O shield. This makes routing cables in a cramped space like a case much easier, so I do very much appreciate that. Furthermore, the connectors are all designed with solid pins. The solid pin design allows for a more stable transmission of 12-volt power to the CPU even when handling high current loads. Moving to the memory subsystem, the Z890 HTI Wi-Fi supports DDR5 memory speeds up to 9200 MHz plus, with 4 DIMM slots capable of accommodating up to 256 GB of RAM. This makes it an excellent choice not only for gaming, but also for creators and professionals needing high memory capacity and speed. MSI's Memory Boost and SMT technology ensure clean signals for stable overclocking. With this tech, they utilize a isolated circuit, so it's a direct path to the DIMM slots to further enhance signal integrity. Now, when it comes to memory speeds, your mileage will vary on this. Memory overclocking is dependent on a lot of things like the quality of your CPU's IMC, the kit you're using, and the layout of the board. Obviously, with this being a 4-DIMM board, it's not going to be able to push super high frequencies like a 2-DIMM board. The board does have support for the new DDR5 CU DIMM modules, so the potential to push higher speeds is there. However, I did some testing with regular UDIMM kits, and I was quite surprised by this board's capabilities, which I'll be sharing my findings later on in this video. This motherboard is also using an 8-layer NPG-170D server-grade PCB with 2-ounce thickened copper, which I would say has definitely helped in memory performance. Around the memory DIMM slots, you'll find a CPU fan header, a pump fan header, and a system fan header. This motherboard has 8 fan headers in total, so there's plenty of cooling fans you can connect to it. We've also got an LED debug display, and these are always handy to have because they display a code which the user can reference from the manual and then find out what's wrong with their system if it's not posting. Along with that, it can double up as a CPU temperature display, so that's convenient. Then we have the ATX 24-pin power connector, which also utilizes the solid pin connectors to enhance power transmission. Right below it, we have the ARGB Easy Connector header for your RGB lighting and fans. Then a USB 3.0 header, and I was expecting to see the header oriented sideways like they had it on previous generation Z790 boards, as that makes connectivity a lot easier. Then we have a front panel USB-C header, which supports data transfer speeds up to 20 gigabits per second and a 27-watt USB power delivery for fast charging. Then we have 4 SATA 6GB ports, which may not seem like a lot, but there is a good reason for that. Then at the bottom of the board, you'll find a plethora of headers, including fan headers, RGB headers, USB 2.0, HD audio, clear CMOS jumpers, and more. What's also new for this generation is that MSI have included a PCIe power connector at the bottom. You'll also find this connector on their latest AMD 800 series boards as well. Think of it as an extra battery pack for your motherboard, an innovative feature designed to enhance system stability and performance during demanding workloads. By providing an additional 8-pin power connector, it supports up to 252 watts of extra power delivery alongside the standard 24-pin connector, ensuring reliable operation for high-powered GPUs, intensive gaming, or resource-heavy AI applications. Usually the motherboard's 24-pin 12-volt power connector can only support a maximum of 168 watts. While this might be enough for basic operations, it falls short when trying to drive everything to its peak, especially these days when folks have a plethora of RGB fans, lighting strips, mini OLED displays on the AIO, and also even fans these days, and you have to run that with maybe a power-hungry GPU like an RTX 4090. The 24-pin and 8-pin power connectors deliver a combined total of 420 watts, giving the entire system plenty of power headroom to operate smoothly, even under the most demanding conditions. Underneath the Audio Boost 4-plate, you'll find the Realtek ALC 1220p codec chip with a built-in headphone amplifier, offering 7.1 channel surround sound and also optical audio output. Now, I'm not an expert in audio and I don't have any extensive data to share here, but I do like my audio to sound good, and I was using my Sennheiser's HD560S to test my listening experience with this board's integrated audio. It had no issues driving them, and as for quality, it was pretty decent as well, above average than what I've heard from most onboard solutions. I also didn't notice any sort of weird static or electro interference noises, which can be attributed to the isolated signal design, so that was great. I tend to pick up on those kinds of things a lot and find them to be quite annoying, but in this case I didn't have any of those problems. Moving around to the rear I/O, you'll find that the MSI Z890 HTI Wi-Fi is no slouch when it comes to offering a wide range of connectivity. It features 4 USB 5GB Type A ports, 4 USB 10GB Type A ports, and a 10GB USB Type C port, providing ample high-speed connectivity for external drives, peripherals, and devices. Additionally, it includes dual Thunderbolt 4 Type C ports, supporting up to 40 gigabit transfer rates, daisy chaining, and 8K display output, ideal for creators and enthusiasts. Rounding out the I/O are an HDMI 2.1 port, a 5GB LAN port powered by Intel's killer networking, Wi-Fi 7 antenna connectors with support for Bluetooth 5.4, 7.1 channel HD audio outputs with optical, and a quick access button for clearing CMOS and BIOS flashback. And there's a dedicated USB 2.0 port that is used for the BIOS flashback function, so you can flash this board without having a CPU installed, and I think that's really convenient. The MSI Z890 HTI Wi-Fi offers a robust selection of expansion slots to accommodate various build requirements. It features a PCIe 5.0x16 slot reinforced with MSI steel armor for enhanced durability and designed to support the latest high-performance GPUs. And finally, they've incorporated an easy release mechanism for the graphics card. They literally call it an easy PCIe release, but with a push of a button that's very accessible, it unlocks the slot so you don't have to dig your fingers underneath the card or underneath a tower cooler. Additionally, there's a PCIe 4.0x16 slot and a PCIe 4.0x1 slot, providing versatility for add-in cards such as a storage controller, capture card, or networking expansion. The configuration ensures users can utilize cutting-edge PCIe technology while maintaining flexibility for future upgrades. Now, speaking of expansion, that brings us to these Easy Shield Frozer plates, which are toolless and can be removed with one finger. I really like this design, no need to fiddle around with tiny screws. Removing those reveals 5 M.2 slots. The first one nearest to the CPU socket is the Gen 5 X4 M.2 slot, supporting speeds up to 128 gigabits per second, and the rest are Gen 4 X4 slots. And just like the PCIe Gen 5 slot, all the M.2s are toolless, one finger operation with their easy clip design. Again, it just makes your life so much easier rather than have to fiddle around with tiny screws that you can lose very easily. If you wanted to get a further understanding of how all the expansion slots are connected, rather than me explain it to you, you'll be able to get a much better understanding of it from this block diagram from the manual, which shows exactly that. You can see what is directly connected to the CPU and what is connected directly to the PCH, which carries over communication to the CPU. There's one thing that I wish MSI did include, and that would be a nice backplate, but I'm not going to zonk them hard for that, as their competitors also don't include a backplate at this price point either. That basically covers everything I wanted to talk about in terms of what's physically on the board. So let's switch our focus to the BIOS, and then we'll move on to some test results. This generation of motherboards from MSI have a new overhauled UEFI. And if you've been using MSI motherboards for a while now, from various past generations, their BIOS had stayed relatively stagnant in terms of design, which wasn't necessarily a bad thing. You know, why break something that isn't broken? But you can see here this new UEFI, at first it looks quite different, and I'm not gonna lie, it was throwing me off, but I would say within 5 to 10 minutes I was easily able to familiarize myself with it, because as you start using it, the menus and the various options you find within those submenus is the same. It's essentially just a reskin, but everything is laid out where you'd expect to find it. When you first load into the BIOS, you'll find yourself in the easy mode section, where you'll find common settings and information that your average user would probably touch and then leave, such as enabling XMP. And then they also have like one-click overclock options available for your CPU and the NPU. Then pressing F7 gets us into the advanced menu, and on the left-hand side, you'll find tabs or submenus pertaining to advanced settings, overclocking tweakers, security, boot, and save functions. In the advanced menu, you'll find settings pertaining to stuff like the iGPU settings, PCIe configuration, USB configuration, and more. And the overclocking menu is where you'll find settings that you can use to tweak your CPU, such as overclocking P cores, overclocking E cores, adjust the D2D frequency, set power limits, adjust load line parameters, adjust voltages, and more. You'll also find a section in there for where you can adjust your memory settings as well as adjust timings. So you'll notice that a lot of the options that you'd see in their previous generation motherboards are still here. They're just reskinned a bit differently, but this should be very familiar to you if you've used an MSI motherboard in the last few years. I also really like how they include a hardware monitoring menu within the BIOS that allows you to adjust the fan speeds from within rather than have to download another software within Windows. So you can easily set your fan curves and profiles here. With that said, MSI do have their Dragon Center that you can download if you like to adjust settings within the operating system, as well as be able to control the RGB settings. So overall, I really like this BIOS. I think MSI took a step in the right direction by taking their UEFI that I guess started to look a bit dated and then modernized it, but still kept everything in a very fluent and congruent manner where you can easily find all the settings in places where they make sense and you're not having to juggle through 5 different menus. Moving on, and I wanted to talk a bit about my memory overclocking experience, and then we'll go over some thermal results. For this motherboard's review, I won't be going over CPU overclocking, as I'll be talking about that in another video that I have planned for the near future, involving a head-to-head showdown of my Ultra 9 285K and the 14900K. Mainly because I just haven't had much time to dip my toes into the CPU tuning aspect of Arrow Lake, as there's just so much to play around with. However, for memory overclocking, I really wanted to go over that, as MSI are advertising speeds of 9200 megatransfers plus, and that's a pretty large step up over their previous generation Z790 boards. This is because the Arrow Lake CPUs have a newer and better memory controller on them, and the boards also support CUDIM memory modules, which has the special clock driver unit on the modules themselves, which is supposed to alleviate any shortcomings from the poor CPU IMC quality, allowing users to really crank up those frequencies. So I don't own any CUDIM kits yet, however I do have a Patriot Viper Extreme 5 48GB 2x24 kit that's rated to run at 8200 megatransfers CL38, and this is the same kit I was using on my Z790 Carbon Wi-Fi 2 test bench, but since that platform was pretty limited on what you could do with 4DIMM motherboards, the most I could achieve was 7600 megatransfers. Now we know the Z890 HTI Wi-Fi is also a 4DIMM motherboard, but I thought I'd just try loading the 8200 C38 XMP profile and see what happens. And when I did that, I noticed that it barely took any time at all to train and it went straight into Windows, no issues. This was already a pretty good sign because memory training on Z790 would take a much longer time. And I ran a memory test and it was stable. So right off the bat, we were off to a good start, being able to run 8200 C38 in Gear 2 right out of the box, and that was already a big improvement over what I could manage on the Z790 Carbon. Also, I should add, even though I didn't delve into any sort of extensive manual RAM timing tweaks, I was using MSI's performance memory extension mode, which further optimizes timings beyond XMP. Then I tried 8400 C38, and that was also stable after a 24-hour test. Then I decided to bump it up to 8600, however it wasn't stable at CL38, so I loosened the primary timings a bit and was able to stabilize it. So I was quite impressed that on a 4DIMM board, using just regular UDIMM memory, we could attain 8600 CL40 in Gear 2. I feel like with a CUDIMM kit, maybe I'd have a decent chance at pushing things further. It's just a shame that Intel's new design involved them removing the IMC off of the compute die, which really took a toll on memory latency. Even with these settings, the latency in IDA was like 73 or 74 nanoseconds, whereas on my Z790 Carbon, despite lower memory speeds, I would sit at like 53 or 54 nanoseconds, but lower bandwidth. So we'll see how that plays out during the gaming benchmarks. Nonetheless, RAM tuning and compatibility with this Arrow Lake CPU and the motherboard has been very easy going, a lot easier than I thought it would have been. Because as I've said in the past, I've spent quite a lot of time tuning DDR5 on Z790 and it wasn't nearly this smooth. Alright, so moving on to testing thermals, I decided to test with an hour-long stress test of Cinebench R23 just to get an idea of what we'd be looking at for the VRMs, PCH, and the system sensor. Ambient room temperature was about 23 degrees Celsius. The CPU was using the default Intel profile, which sets PL1 and PL2 to 250 watts and the current to 347 amps. I ran the test 2 separate times. The first test was just involving the board itself with no airflow, and my 285K is cooled by the MSI E360 AIO, but it's exhausting air away from the open test bench. So while this test run shows you how the board handles cooling itself, I guess passively, it's actually a unrealistic test because in an actual case there will be airflow over those components. So the second run I had a 140mm fan running at 800 RPM on top of the test bench, which I typically use to cool my RAM, but this will also function as active cooling for the board. During our first run, you'll see the VRMs did decently with no airflow on them. They averaged 61 degrees Celsius and peaked at 68°C over this 1-hour stress test. We can also see decent temps of the PCH at 58°C average and a peak of just 64°C. The motherboard sensor temp, which I believe is near the bottom half of the board, averaged 43°C and a peak of just 48. And the socket temp, not to be confused with the direct CPU temp, was also decent at just 54°C with a peak of 57. So overall, I can't really complain about these temps, especially when there is zero airflow over the components. Now, when we introduce some airflow, we see much better results, and these temps would be more aligned with what you'd see from a setup inside of a PC case that comes with adequate airflow. Our VRMs benefit the most from this scenario, just 44°C with a peak of 47°C. Then when it comes to the PCH, we did see an improvement, though not by a huge amount as it sits in the lower half of the board, and part of my 4090 obstructs airflow, but 51°C average isn't anything problematic when these things are rated to run at like 100 degrees Celsius. Not that you should, but it gives you an idea of how much headroom you have for operating temps. The socket temps also went down by a bit, and then our motherboard system sensor also went down slightly. So yeah, overall, temps on this board are just absolutely great. To wrap things up, the MSI Z890 Edge TI Wi-Fi is a well-rounded motherboard that delivers a lot for its price. With its excellent build quality, advanced connectivity options, robust power delivery system, and thoughtful features like the RL-ILM and Supplemental PCIe power connector, MSI has crafted a platform that caters to gamers, hardware enthusiasts, and creators. The striking silver and white aesthetics are a refreshing departure from the norm, offering a clean and modern look that will elevate any build, especially in a white or light colored case. Whether you're aiming for high-end gaming, heavy multitasking, or overclocking, this board is built to handle it all. While there are a few areas where minor improvements could be made, such as including a backplate, beefier power delivery, or tweaking header placements, they hardly overshadow the impressive feature set of the whole package. Overall, the MSI Z890 Edge TI Wi-Fi stands out as a compelling choice for those looking to build a powerful and reliable Arrow Lake-based PC. If you're interested in picking one up, I'll have an affiliate link down below in the video description. That's going to be doing it for this one. We'll be touching base in the next video.
If you guys found this video to be informative and entertaining, then leave a like. Let me know your thoughts and comments down below. Be sure to check out the video description for cool links and ways to support the channel, such as using my Amazon affiliate link. And if you're interested in seeing more content like this, then consider subscribing. I'd greatly appreciate it. Thank you guys so much for watching, take care, and I'll see you in the next one.